Good afternoon to all. I, Soumya Gunlatoti, heartily invite you all for today's PU webinar on the topic Introduction to Aircraft Maintenance. This is mostly interesting and trending to aeronautical stream. I'm pleased to inform you all that we have Mr. Sai, GET, Aircraft Maintenance Engineer from Air India Engineering Service Limited. Before I invite Sir, grant me an opportunity to brief and introduce him. Mr. Sai has completed his BTech Aeronautical Engineering from JNTU in year 2014. Sir worked in various industries for 6 years with Genpact, Giant, and currently with Air India. And he also has given training to many students regarding CATIA and structural analysis. To introduce Air India services, Air India Engineering Services Limited is the biggest MRO setup in India that can serve as one-step shop for engineering services of aeronautical. AIESL comprises of huge infrastructure to cater to line maintenance, base maintenance, engine overhaul, accessories overhaul, and component overhaul activities as per capability at main bases and lane stations. Duties performed by SAI, aircraft maintenance activities, quality and assurance activities, production planning. Okay, now I invite Mr. Sai to share his knowledge.
Yeah, hi everyone, this is Sai. As Soumya has mentioned, I was like, I have 6 years of experience. I have 6 years. I think there is a lag in. Hello. You can hear me, right?
Yeah.
Okay. Yeah. So
yes,
what I was saying. Okay. So I have 6 years in experience. So first year I worked as an CATIA trainer for 1 year, including CATIA ANSYS and National Pattern. And thereafter I worked for 2.5 years in Genpact for engine health monitoring, where we use it to monitor the G engines like CFM, G90, GNX, and LEAP engines. So we used to get a lot of data through sensors like temperature, pressure, the end speed. I mean, core and fan speed, which I will be explaining in further classes if anyone doesn't know what it is. And next, I worked as a reliability engineer, which is also known as quality check for Pratt and Whitney engines. And then I joined in 2018 Air India, which I'm currently working as an aircraft maintenance engineer, where we deal with the various departments, not only maintenance, but also we do the quality checks as well as we work in few labs as well. Because engineer doesn't only mean that you will be working on aircrafts. There are many systems related to aircraft like hydraulics, fuels, landing gear system, and etc. So we even deal with those components, and we make. Finally, what we do is to make the aircraft airworthy. That's it. So, anything I can start with the session, or any other is required from you?
No, you can start with the presentation.
Okay, I'm just also checking the your messages as well as the questions. You can interrupt me anything if you find it like questions in during my presentation. Okay, I like it to be to and fro presentation, because me saying all the things and you just guys sitting it stuff will be a bit boring. So let's have like a conversation thing rather than a class. So thank you for this opportunity. Okay, let me first start with the what is maintenance, what are the aircrafts, and how we will decide which maintenance to do on it. Okay. Okay, you all can see my screen, right? I think I haven't shared.
Not it.
Oh, sorry. Yeah. Soumya, you can see my screen right now. Hello. Can you guys hear me?
Yes, we can hear you and we can see your presentation.
Okay.
Students, if you are having any questions, you can give in the chat box also.
Okay. You can see my screen right now.
Yes.
Okay. So let me continue. Okay. So introduction to aircraft maintenance, what we will be discussing initially in this session. So first of all, what is before maintenance? We just can go through a briefing of what actually our aviation industry is. I think most of you guys are all from aeronautical or mechanical background. So this is how our flowchart structure goes. First, design. We will design an aircraft depending on the requirements of the customer. Okay, always customer is the main point where we value our resources or the works. Okay, so first we design and we test it. Is it working? The testing is done in two phases. Like one is like software testing, which you guys do. One is also the real time testing, like in the labs, what we UTMs and all those things we use to test the other things. Okay, again it will go back to the design phase until unless it gets approved. So testing and design goes hand in hand, where it is shown in the flowchart like step by step, but in real phase it will go hand in hand both. Okay, then it comes to manufacturing, and during manufacturing we will be finding some issues again, like you will draw it better in the 3D view, but when it comes to manufacturing, the curves, signal, like rips and all those things, where are those are in I section, right? So some of the new development is like S-shaped I section beams. So those are very easy to do in the designing and testing during systems. But when you are coming to manufacturing, it is very hard to produce. So when you are finding these issues, again, you will go back to design and testing phase again. So after finally, when the products come out, then the aftermarket services comes. These aftermarket services are nothing but the issues you will be finding or problems the customer is facing in the real time or during the test phase. For example, you have designed an aircraft and you have given, you can't sell it right away. First, you have to fly it for the 5,000 hours. That's a rule set by ICAO and various governing bodies of aviation, where it says that once you design a new vehicle, you have to test it for certain amount of hours. It has to flew perfectly so that it can be set it can enter into the what you call final production phase. Okay, so aftermarket services is that it when during testing, real-time testing, and during the while the customer is using, whatever he faces the issues will be dealt with all the aftermarket services. As I said, my first company, I used to deal with the data which is coming back to the us from the engines, right? So for example, we used to get the data like vibrations, and fan speed, EGT. EGT is nothing but T3 temperature probe. After the, I think you guys all know the Brayton cycle, right? Soumya, these guys know the Brayton cycle?
It's audible. Everything is clear.
Oh yeah. Okay. No. I just was asking. These guys are enough to know Brayton cycle, right? Are there any first years or everyone is second and third years?
No, everybody's fourth year, sir.
4 years. Okay, that's great. Then you guys will be knowing the Brayton cycle and basics of the theoretical part. So that probe after the propulsion thing, which we get is what we use it to call it as EGT, exhaust gas temperature. Okay. So we measure that depending on the various values and combination of values, we will be determining if engine is working in a condition or it is not in the condition. It's a big chapter. If we have a further anything, I will be discussing that in another session. So let's go back to maintenance then. From the recommendations of manufacturer and from the aftermarket services, we will be doing maintenance in the real-time field. For example, he says like your engine is having high vibrations, just correct it. And he will give you the set of instruction what you can be doing for correction. So maintenance guys, open the fan, blades. There are weights which will be holding the vibration in check. We'll be checking all of those and doing the corrections. As well as fuel, if you got clogging, remove the filter, clean it and done it. If you have any system hydraulic problem, remove the motor, whatever the issue, remove the blades or check the blades, everything like that. We will be checking it. Okay. So maintenance, like you are the repair guy for servicing, you will give it to bikes or cars, right? It's similar to that. And finally, the airworthiness. Airworthiness is nothing but keeping the aircraft safety in air. Okay. That's what airworthiness is all about. To do aircraft to fly in safety, yeah, pilot should fly it well, but aircraft should also be in a good pristine condition, because if the aircraft, it's not like a vehicle that on land, right? If you get a tire burst or anything else, you just park it on the side of the road and get it maintenance done. You can't do that. So you have to predict the issues and get it maintenance done, and that's how you will be maintaining the airworthy. Okay, as of now, airworthy and air safety are also a big kind of a topic. So I'm not covering those topics in the session. Today, I'm only focused on maintenance and a few more problems which we focus during the maintenance, and I will be discussing them with you. Okay. Okay, this is just a briefing of aftermarket services. What generally, because you guys like, if you divide our working structure, out of the 100% of the aeronautical engineers, hardly 10% will go to design or testing. Okay. In manufacturing, from manufacturing, aftermarket, maintenance, airworthiness, 90% of the people will go there, because it is having a broad scope of and requires many people than design and testing. Okay. So in aftermarket services, what are all the topics that can be covered? First is health monitoring, is nothing but live analysis of the data which you get hit. Okay. And next is the tech publication. Tech publications are nothing but the technical documents. For everything you can't, there is a one simple rule in the aviation, not only in aviation, in the industry, that no data should be transferred through mouth. I mean oral transformation. Everything should be done through documents, because one can say one thing and the person hearing that can assume it in a different manner. So to avoid such conflicts, the rule is passed down like everything should be documented and every design should be noted down to the last bit of the detail, so that it is perfect in every sense. Okay. So tech publications are these guys who record everything and get down the time. Like, what is the engine diameter? I mean, intake diameter. What is its length? Blade angles, NACA series of the blades. Everything will be noted down by them. Okay, tech operations are nothing but these guys take the data from the publications and make it airworthy reliable. Okay, like tech operations, nothing but AME will come into it. Technicians will come into it, and all the other staff who are working in maintenance. Okay. And field service engineers are nothing but the engineers from the aircraft point of view. Okay, maintenance is a different group and aircraft or operator is a different group. Aircraft operator main purpose is to make the aircraft fly in and in time. Like if you have a flight is going to be take off at 7, he will make sure it will be take off at 7. But tech operations main purpose is that aircraft should be airworthy, like perfectly in condition to be working in. So I think you guys get the difference between both of them. And any of you have any questions regarding it? This aftermarket services? Hello, Soumya. Is there any questions regarding this, or shall I continue?
I hope so. There is no questions. You can continue.
Yo, okay. Am I going too fast, or is it fine, the speed?
This is okay.
Okay. Okay, good. Then I will be continuing. Next is the airworthiness, which I said the other part after the like maintenance, right? Sorry. Okay. So airworthiness, air safety. So to do any work, you need a governing body. So for governing body is like a police thing or politician, right? Which keeps everything in a rules and restrictions so that every person has to follow those. If not, it will lead to accidents and other crimes. So ICAO is International Civil Aviation Organization, which deals with all the civil aircrafts like air paths. When this path, every flight which take part has a flight path, which is also restricted by time and place. So they will give the instruction where it has in ICAO there is another small part like International Airport Transport Association, ITA. So this will take about mainly about that if you've seen in cinemas like towers, like control towers, flight path guidance, everything will be taken by these guys. ICAO mainly set the rules, like you guys are having safety precautions. Are you following it or not? Every base, like it is again divided into many structures like schools, maintenance organization, manufacturing. So different divisions have come under it, which transport is one of the division. So which they assign rules to everyone and to follow it. So again, ICAO is like an international organization. So again, each and a country, not each and every country, but most of the countries have its own governing bodies again inside this their own country, because they can't follow the international rule, right? They have to make sure that their own country is safer. So which similar to ICAO, the governing body in India is DGCA, Director General of Civil Aviation. Okay. So similar, air traffic control comes under it. So these are the governing bodies. And these include just DGCA. It takes around like reading all of it will take you around at least 30 classes. So it's a big topic as well. So anything briefing if you need regarding these 4 things, let me know. Soumya, anything else? Can I continue with this?
Yeah, you can continue.
Okay, I think no guys are having any questions regarding it. Okay, fine. So let's come to our main topic, maintenance. First, I mean, there are many persons who work in the maintenance, but main 2 categories which we consider important are engineers and technicians. Okay, engineers are nothing but all the persons who have having the authority, certifying authority, which means they can say that this aircraft can fly well, or this part of the aircraft is in working condition. So, for example, if there is any fault, if the engineer says it's working fine, and if it says is there any fault while flying, then there is a chance that engineer can be banned for life for not working in aviation field. So that's the very critical part of the engineer. So he should be thorough with everything he has to be done. And I will be briefing like there are different classifications in engineers as well, depending on the departments they are mentioned. Okay, so mainly engineers work in 2, like divided into 2 fields. One is major, one is line. Line is nothing but during landing and takeoff. Before takeoff, there is a few pre-flight checks to be done, like if tire gas is what you call in limited pressure or not. If landing gear is hydraulically filled, or oil levels of the aircraft are in within limits, or the EGT is anywhere beyond the limit. Everything, like there are 30-40 checks which they have to perform before the pre-flight, and they will be doing for every flight that comes landed, and before takeoff they will be taking it, and we call them as pre-flight schedule in general terminology. So the person who is responsible for certifying that is called as line maintenance engineer. Okay. From line maintenance will handle till weekly checks, right? Weekly is nothing but 8 days check, and bi-weekly is like 15 days check. So they have a authority of checking it till 15 days check. Any checks to be performed beyond 15 days should be handled by another engineer called major certifying engineers. So have you guys heard of the term ABC checks? Anyone? Guys, no one? So, Samir, is it an open line or a closed line?
It's an open line. Only for few people, it's an open line.
Yeah, it's open for few, right? But they are also silent. Okay. Just guys, say it yes or no. Nothing is a thing. Do these guys know ABC checks?
Yes, I think so. They have known about it.
Okay.
Just as an introduction.
Okay, I don't think I have mentioned anywhere. Okay, fine. A, B, C checks are nothing but checks to be performed in a periodic checks. Okay. For example, if you buy a new bike, they will ask you to do first 5 checks for free, right? Like for 30 days you have to check, and 60 days you have to come again and make their servicing, right? In similar way, aircraft also given some specific amount of time to make it check. Okay, A is for 30, 6 is for B is for 90, and C is for few aircraft 1.6. I mean 1 year 6 months for other few aircraft, and D is for 12 or 4-year check depending on the aircraft. Okay, so depending on different types of models, we will be having a different types of periodic checks, and technicians work under engineers, which is majorly like removing a component or mechanical work. Everything will be done by technicians. Okay, before you become an engineer, at least you have to have a 6 months or 1 year experience as a technician, so that you will hands get adjusted to the tools. And as you are from what you call engineering background, most of you guys never touch the tools, wrench, screwdriver or anything. It will be better even if you can repair your bike. That hands-on experience is a must if you are coming to maintenance field. Otherwise, it will be a very what you call we will be facing a big problems later on to overcome those issues. Okay, so you are 4th year guys, so you don't have much time. So you have to grasp as much as possible as if now. Okay. So later on, shops are nothing but there are only few tasks which will be done on the aircraft, right? For if there is a component like a booster pump or what you call pumps, you guys should know pumps, generators, right? Valves. So these things, if you have any issues or electrical components issues, you won't be working on the aircraft, because there is two problems. Mainly is like it is not clean, because even the aircraft is kept clean, there is always will be a dust in the aircraft, and it is not easy accessible is not there. So you remove those components and take to our respective shops so that you will work on it. And some of the mainly for electrical components, those are DSD devices, like electrostatic devices, EDSD we call it, electrostatic sensitive devices, or some its full form is. So if you work on them, it will be short circuited. So you have to wear gloves and electrostatic free base, like you will be keeping carpets everywhere where you kept those components. Okay, so every component has its own restrictions, so which can only be worked on shops. So shops is a part of major hangar. I listed only few of them. I'm mainly belonging to the structure, mechanical engine part, not the electrical. So I defined some of the mechanical and electric as well, but mainly mechanical. Structure and composite shop, where you will be repairing any physical damages on the wings outside structures like stringers, ribs, spars, or skin of the wing, fuselage, leading edge, I mean everything. Okay. The flight recorder. Flight recorder, again, it's an avionics part, what we call, you guys known as electrical thing, which we also call as avionics in aviation industry. So flight recorder is nothing but it records everything it flown in the aircraft for 2 hours, and video will be recorded for 30 minutes. So if during the people from the crash investigation will hear you. Like you guys have heard of black box, right? This is what black box contain mainly. And it mainly tells you about what happened in the aircraft. So any of you guys ever heard the flight recording? Oh, still silent, huh? Soumya, any idea these guys have heard any flight recordings?
Everything they will be regarding like a inspection part, not the depth of the knowledge.
Okay, fine. I may send her some
like the components.
Yeah, right. So flight recorder, you can find it in YouTube, like few of them during investigations. So I may send few links to Soumya. You can just pick it from her after this class. You guys, YouTube is a big thing. You guys should get a source of it, what you want. Okay. Next, the flight recorder is fine. NDT, I think you guys know what your theoretical part better. HEFC is high frequency eddy current. LFC is a low frequency eddy current. Depending on the depth and the thickness of the material, you will be switching from HF to LF, low to high frequency. UT is ultrasonic testing. It also measures the depths, depths and dents and thickness. You can measure with these three. Particle testing, diparticle testing, fluorescent. You guys, I think last session your senior said they have seen the fluorescent. So diparticle penetration testing and all those things, you guys should be knowing those. And wheelbase is nothing but technically you say that wheel is nothing big, but it's having its own various maintenance, like how much the thickness of the tire tube is, how many layers it is ruptured off, because during landing and not takeoff, but during mainly landing, there is a huge friction going on in the tires, and even in few times you can observe there is a spark coming out, right? So that makes the outer layer of the tube wear off. Okay, there is a certain limited restriction how much the wear off can be done and how much time you can rethread it, and those all things go technically in the wheelbase. Welding, anyway, you know, like any damages or breakages or scratch, it's there. We will clean it off, rinse it, and then we will start welding if it is in within the allowable limits. Everything in the maintenance can be done during the allowable limits, and we will be given those instructions by the manufacturer itself. We call that document as AMM, Aircraft Maintenance Manual. I think I have few slides regarding it. I will explain it to you on the later sessions. Okay, these all things are fine, but maintenance, what kind of maintenance you have to done depends on the what kind of aircraft you have. For example, we have these pictures are shown like different sizes of aircraft, right? From the left top corner, Airbus 380, which is a wide body, we call it, and to right top corner, just as business aircraft. The ranges, sizes are different, so the systems are different, and type of maintenance to be done on it is different. And even the aircraft who can maintain the wide body cannot do the maintenance for the business jet. Every aircraft type has its own maintenance engineers. Yes, one can get a multiple thing, but only within the specific scope, not everything, right? So these four aircrafts are, first is wide body, top left corner, and bottom of that is narrow body, and top right corner is also narrow body, but we call it as regionals. Like it is not allowed to flow more than 4 hours, I think. ETOPS, there is a certain rule set by the ICAO, ETOPS, and recently term changed it to EDTO. It's nothing but extended twin operating procedures. Okay, how much an aircraft can fly, depending on the aircraft type, they have defined it, and depending on engines as well. Okay, so you can't have an aircraft can flown in every region. It has to meet those specific conditions to be flown. Okay, and the bottom one is computers, business, and trainers. Those are mostly handled by the business people or for training purposes, or aviation, like Air Force test pilots. Okay. So any questions in type of aircrafts?
I think so. There was so many broad, I mean, other types of also aircrafts are there, right?
Yeah. So if you can, there are different types of aircrafts, but if you take a civil aviation aircraft, it will be broadly classified into these four parts. I'm talking about only aeroplanes, not aircrafts. My mistake. Terminology has changed recently. Aircraft is nothing but everything which flies is known as aircrafts. So helicopters are also included, but I'm only speaking about the civil aviation aeroplanes. So if you come into civil aviation aeroplanes, there are different types, but all the four types will come under these four classifications. I hope I answered that question, right?
Yeah, thank you.
Yeah.
You can call.
Okay, fine. So yeah, these are all 4 years, right? Hello?
Actually, it is open for everyone, but now in the loop, there are few fourth-year students are there.
Okay, everyone are there. Okay, fine.
Yes, it's included with the faculty, all the PO, everybody is there.
Okay, fine. So I will get to bottom of the level as much as I can. Okay. So there are many types of engines because development is happening every day, but mostly what we read about is these 6 types of engines. Okay. Turbofan, turboprop, turboshaft, turbojet, scramjet, and ramjet. And out of these 6, scramjet and ramjet are only used mainly in like fighters and all those things, because its output is very more, and its fuel to fuel to thrust ratio efficiency is very less. So depending on that, so only the 4 engines, because I belong to the maintenance of civil aviations, so we only be focusing on the 4 engines, top 4 engines: turbofan, turboprop, turboshaft, and turbojet. Okay. So there are 4 types of engines. So anyone have idea, depending on what factors do we select an engine for a particular type of aircraft? Still, guys, you can speak. Soumya said some 4 years are in the loop. You guys are too silent. Okay. Fine. So anyone has
No, if there is no answer, that means there's no questions. You can call.
Okay, no. I was just asking them the back question, saying that if anyone knows what is the difference between all those 4 and why they are using it.
By the end of the college
Yeah.
or the university, or by the starting of the job, they will get so many questions. Now you can
Okay, fine.
carry on.
Okay, fine then. I will carry on, guys. Just my personal like thing. Suggestion is that as long as you only hear a session, it won't be helpful for you much, because unless you get a question, I mean, if you understand everything, it's a good. But no one understands 100%, and unless until you get a questions or think about why and what we are doing this for, sessions are not much useful to guys. Okay. So, okay, fine. Anyway, so let's continue with type of engines: turbofan, turboprop, turboshaft, turbojet. Okay. Uh, Depending on the region where you are flying, depending on the dimensions of the aircraft and the size, weight of the aircraft, these are defined. Okay. For example, let me take this diagram back to these pictures. Okay. The first left side aircrafts. Okay. Is a turbofan engines. In general, heavy aircrafts are used by turbofan engines, because it has a high bypass ratio, which gives you high thrust for longer periods of time. Okay, and high altitudes. When you are having a need a requirement of aircraft which needs to be flight at higher altitude for long amount of time and having a large weight, you need turbofan engines. Okay, it will give efficiency in during those times. Again, if you having a aircraft not to take much flights, like not intercontinental, before what we discuss is our intercontinental or inter countries, changing of countries. If you have a need of an aircraft where you need to fly only from, like for example, say Hyderabad to Delhi or Gujarat or any other local within the India, okay, then you need a aircraft with low altitude, not high altitude like 10,000 feet, and not much heavier aircraft, because 72 seater or something is fine enough, because not 300 people will travel every day from Delhi to Gujarat or other places within the country, right? You need a smaller aircraft where like 72 seater or something, or like business jets or whatever. So these require a turbo propeller engines. Okay, this doesn't have a bypass. These have a low bypass but high thrust. What you call low thrust compared to turbofan engine, but high bypass compared to turbofan engines. Okay, because the bypass is not restricted by any cowl, right? It has an open bypass system, so bypass air is just navigated through around the engine, right? So there is no limitations for bypass, so it has a high efficiency. But because it is not taking a bypass inside the cowl, during high altitudes, due to the pressure and density drop, its efficiency decreases. So during low altitudes and for low low distances, it is very efficient. So so depending on those things, we will be choosing the engine. And turbo shaft, mainly turbo shaft is used not to propel. I mean, these are not thrust producing like these two engines. In helicopter, you will be using turbo shaft engines, where you have to just rotate the fan blade instead of producing the thrust. Okay, torque is required. Where torque is required, turbo shaft is used. And I guess you guys should have heard about APU engines, right? Anyone heard about what is APU? Soumya, these guys have idea about APU?
Yeah, they have idea.
Okay, they're good. So APU is nothing but a mini version of an engine, turbofan engine, which kept at the rear end of the wide and narrow body, few of the all the wide bodies and few in narrow body aircrafts to start up the engine aircraft. Okay, those are APU engines. Turboshaft engines are APU used in for APU and helicopters. Okay, turbojet is used in missiles as well and few aircrafts as well, where it is nothing. Let's discuss in future what is the difference between turbofan and turbojet. Okay. Here you can see, right, in my slide, there are two engines. Top one is turbofan and bottom one is turbojet. Okay. Uh, as you should be knowing, the core parts of the engines are compressor, combustion, and exhaust. Okay. Uh, so compressor, combustion, and exhaust. Okay. Only if you have the intake, compression, and combustion and exhaust without any bypass thing, it is called turbojet engine. Okay. So for example, if you insert a bypass around the engine in the initial value here, if you can see the mouse on the screen here, just insert a fan and close it like a curvature around it, like closing of a cowl. So it becomes the turbofan engine. So there is not much difference between turbofan and turbojet engine. Just one has a bypass and other doesn't have a bypass version. That's it. Okay. If you open a turbo fan engine, it almost looks like this, similar to turbojet, excluding the fan part. Okay. Let's go to turbo propeller engine and a turbo shaft engine. Okay. Here, if you see bottom one is a turbo propeller engine. Okay. It's a little complicated engine compared to turbojet because it has a mostly all turbo propeller engines mostly have a compressor combustion chambers. Centrifugal compressors, which will be having a backflows. So it is a little complicated to study the flow dynamics of these engines. Okay, the bottom shaft is the core one, and this uppermost shaft, where my mouse you can see, is connected to the propeller here. Okay, so that's why it is called as turboprop engine, and the topmost is turbo shaft engine. It's nothing but a normal turbojet engine. At the end, the shaft is extruded into the gearbox, which is and then connected to a fan or a rotary part, anything which you require. Here it is connected to a fan like a helicopter, but in APU you will just have till here only shaft, blue shaft. It will be connected to the generator from their port. From there it will be giving the electric power to entire aircraft during the starting of the engine. Okay. And anything I think your subjects cover more in detail regarding these engines, so I'm not going in depth. So, and if you have any questions, let me know on these 4 engines. Okay, no questions. Okay, let me continue with the type of maintenance. As we discussed, like this is like ABC checks. Initially, this just a slide saying that what and all will come under different departments. Line will be dealing with the transit, weekly and bi-weekly. Transit is nothing but the type of check to be performed on the aircraft before and after before the takeoff. After coming to the hangar and before takeoff, whatever the checks you perform comes under transit checks. Okay. Weekly is performed on the aircraft after 7 to 8 days. Okay. There are certain filters to be changed, tires to be changed during weekly, and bi-weekly is also similarly, but it is performed for 15 days and more tasks are added. The number of days increases, the more number of tasks get added to it. Okay. Major check, these all have a restriction of time. For major, it will be any aircraft coming to major will at least be available for 2 days for A check. B check, it will after flying for 6 to 8 months, it will come to B check and it will be staying for 1 week. All the maintenance tasks required for B check to complete will require at least 1 week, and for C check it will be requiring at least 15 to 20 days, and D check it will be aircraft will be staying for around 1.5 months in the hangar. During D check, we will be removing every like skin. We will be top removing that, checking each and every stringer, frame, ribs. All the structural part will be mainly focused in the D check, because it will be having like after aircraft flying for 4 years for ATR aircrafts, and I think 8 to 12 years for Airbus 320s and all those things required D checks. Okay, so when you do these checks, you will be finding some issues which required a recording and reporting. As I said, no any topic or discussion should be done orally. That's a rule in aviation. Everything is recorded on the paper, and only those things will be considered legitimate. Okay, if you say there is an issue, for example, you have repaired some motor, okay, or a wall, there is a breakage in wall, you have removed it, and you have to you have completed your shift, and you have to give this detail to the next coming engineer. You can't say to him that I just removed this butterfly wall during the air conditioning system main butterfly wall. You can't say just orally. You just have to write it down in the report. There is a report where you will be transferring the topics to the next maintenance engineer. Then you have to write it down everything. Like these are the snacks. Snacks are nothing but the issues you find out during the maintenance thing, and you have to write it down and give it to the next engineer so that he will read your report, and then he will be performing that task, and then later on it will be continued to different engineers depending on the number of shifts it takes to rectify that issue. Okay, so recording and stuff requires is depends on different what you call different stuff like procedures depending on the different types of people they are reporting. Okay, first are ADs, airworthiness directives. These are the issues which has come to the concern of governing bodies like DGCA, ICAO. They release these airworthiness directives. For example, let's say you all people who have flown in the aircraft, you will be sitting in the seats, right? Next time you go, just check it at the bottom of the seat. There will be a track, like train track. There will be a seat track where the seat is inserted inside it. Okay. Recently, there is a directive saying from the DGCS saying that there is a fault in some of those repairs. Okay. Or there is a small fault in the hat track. Hat track is nothing but the space where you keep the suitcase. There is a screw loose in that, so that head track may fall on the customer's head. Okay, so they have released some certain directives saying that you have to change it. Okay, that's what ICAO does, like checking the safety precautions and getting to stuff. Now, what is service bulletin? Okay, fine. DGC has said that to change it, but how to change it? What to replace it? Like you can't bring a bolt from bolt or screw. You guys know, right? Nail, bolt or screw or nail from the shop, outside shop, and just come and fix it, right? You can't do that. You need some specifications. You have to change with MAS or NAS some 650 something. The number will be there. You have to remove this particular bolt and replace with this particular bolt. There is a specification to that. So service bulletin will come from the manufacturer, which covers those all topics, like which part has to be changed from which version to which version and which bolt to which. Even the minute details like how many threads it should be come out after the nut is fixed. It will be to that specific detail that will be recorded in this service bulletin or AMM. If service bulletin is not recording it, it will be related to again AMM, which is aircraft maintenance manual, which will be saying this stuff like what to do, how to open the bolt. You have to remove, turn it clockwise to remove and anti-clockwise to close it. Every part will be recorded in that. Okay, you just have to know how to look at the manual. If you know that, everything can be found within minutes how to do it. Okay, and next is the tech reports. Tech reports are nothing but for example, if there are no reports from the manufacturer or governing body, but pilot has maintenance engineers has found some issue while repairing. He has seen some leak, hydraulic leak coming out of the pipeline, and he have seen for certain aircrafts like 4 to 5 aircrafts, he have seen that issue raising continuously. So then he will make a report and report it to the governing body of the manufacturer depending on the type of topic, and these are called tech reports. They will send to those and saying that there is an issue in certain component. Check it if you have to change the version of it, or send us the manufacturing like preventive measures for it. Okay, So these will go to and back and forth for discussion, and it will come back. So those are technical reports. Okay. Snag report is again given by the aircraft engineer. But this is minute continue. For example, as I said, from one engineer to other during shift change or anything, they have to write a report to pass it on. These are called snag reports. And even sometimes pilot, because pilot is the main person who flies the aircraft, he will be facing the most of the issues during flight. So he will note down, like, for example, I am increasing the temperature of the cabin, but it is not increasing. Or there is an oil leak. Oil pressure is rapidly dropping when I am running the air conditioning system or APU, or APU is not starting properly, or fuel valves are not opening, or anything like kind of stuff. The pilot records. That is called pilot defect report. And cabin defect report are nothing but the reports which are given by the air hostess who works in the who are with the pilot, but not much of the knowledge. Like, they don't write much, but what they write is like, there is a coffee maker in the aircraft, right? Coffee makers like ovens and other stuff. Like there is also monitor in front when you are going in 320 or 380 aircraft. Just check while you are climbing. There will be a left side monitor to check everything whatever the aircraft is having. Okay, or the seat is not reclining back. All those issues, minute issues. Not or sometimes a pilot can't check the smoke while coming out of the engine, but cabin crew, while they move back and forth in the aircraft, so they can see from the window if there is any smoke. So those kind of stuff they report in the book called cabin defect report. So there is a rule saying that pilot defect report and cabin defect report should always be in the aircraft, no matter what. And when aircraft lands on the ground, the first thing the maintenance engineer do is go check these two reports, and there will be a computer in the aircraft where he checks there are any technical snags in that. Okay, so that's how the recording stuff and maintenance mainly starts from that point. And I don't think so. You guys have any questions regarding this?
No, we got a little bit more information rather than normal academics.
Okay, yeah, that's good. So I hope you guys have more questions in my future slides so that I can be thorough, that you are at least understanding what I'm trying to say. Okay. As I said, there is an AMM book, right? So we will be discussing whatever maintenance does will be available in that, and wherever you go, a maintenance engineer, it's like a Gita for maintenance engineer. So he should know about it every time where he goes. Okay, so those like index. So you can't have a AMM. I will be saying AMM from now on for aircraft maintenance manual. Okay, just follow it up. So for AMM, every manufacturer produces it, right? Airbus has its own AMM. ATR has its own AMM, Boeing has its own AMM, and even the Pratt & Whitney, which defines an engine, has its EMM, we call. Instead of aircraft, we call engine maintenance manual. So has their own manuals, okay? So, but you can't go and write your own index every time, because, for example, I'm working in Airbus and I'm now working in Boeing. I can't suddenly switch to Boeing if you have your own index. So what ICAO said is like, they set a certain index. They have said this index should be like this only. So all the AMMs or EMM should follow this index. Okay, this index is widely known as ATA. Aircraft. I forgot what is the full form. Okay, I will be checking a full form. I forgot. ATA. We call it ATA chapters. Okay. So ATA chapters like 1, 2, 3, every number has its own definition. For example, I have showing you 18, but I have highlighted few which we will be working mainly. Okay, 5, 6, 9, 10, 11. Okay, these are the few. These are not important, but these are the things which we consider while maintaining some maintenance, and these are the low priority basis. What I am showing on you on the screen. Okay, time limitations and maintenance checks are nothing but if you have a rib ribs right in the wing where the fuel is kept. So after certain amount of time, it can erode or corrosion or erosion occurs. So there is a check to be performed on the skin plates or ribs or plates. So those are all maintained from timely checks. It will be defined in that. Area and dimensions are nothing but what is the thickness of the skin. I hope I can share with you. I will check it if I can share with you some of the thickness diagrams and ribs. What is this stringer 1, stringer 2, stringer 3? What are all those things? It will be defined in the dimension and areas. Okay. 9th chapter, towing and taxing is nothing but taking. You won't waste the fuel of the aircraft doing moving the aircraft during on ground. So towing and taxi are the rules to be followed while doing that. Parking, storage is nothing but if you are storing the aircraft for 7 days, 15 days, 30 days, or 1 year, 6 months, there are different types of procedure to be followed. You can't just leave the aircraft in open just like that. We will leave the bike for few months, right? If you are not using, but there are certain restrictions for the aircraft to be followed to do that. If you don't use it for certain amount of hours or days, okay. Placards or marking are nothing but just next time when you go to the airport while climbing the aircraft, just go to the bottom of the wing. Okay, just see that you will be having a small stickers. Even on the engine, you will be having a sticker saying that this is a safety zone. You shouldn't come inside of it, or it is a fuel filter has kept here. This or this is a booster pump, or this is a NACA airfoil, or this is a rib number. This is a magnetic fuel chip detector component. In the below of the wing, you can find clearly more than the engine. All those stickers and placards. It's so deep. This chapter is even it will be prescribed how much the letter alphabet size should be while during it is printed on it, and which angle it is to be placed, and at exactly how much length from the leading edge or trailing edge it's to be placed, and even the what you call bold, italic, the style of the nameplate it should be used. Okay, so till the basic description it will be mentioned everything in these chapters. Okay, so let's come to our main topics. This slide which you are seeing is the main topics which we be working on the aircraft, and all the board are working every day. Okay, from 20 standard practice manual, if you are going about 10 feet, you will be wearing a helmet. And if you are using the oil, or then wear a gloves, related gloves to that. And if you are working in a dark environment, you have to use a light. And if you are working especially in a fuel tank, there is a fuel tank safety procedures separately. You can't use a normal light there, right? It will catch a fire. Or you can't keep a cell phone in your pocket and go into the fuel tank. Yeah, you guys, I don't know if few of them knows, but you can go into the fuel tank, right? You can go inside the wing, inside the fuel tank, and you sometimes have to change the sensors. So while doing that, you have to follow certain precautions. So all those will be completed in the standard practices. And this is 24 is mainly for structures airframe. You will be having a follow-up in the subtopics in the 20 chapter as well. Okay. Air conditioning system is AC, as you know. When you are sitting in the aircraft, generally it is meeting 18 to 21 degrees, I think. It depends on the region as well. Those air conditioning systems have AC is nothing you can just change a temperature. It has a very complicated system where the pressurized air is taken from the compressor. During the starting of the compressor, it will be taken from LPC. Soumya, they know about LPC and HPC, right?
Yeah, they know about LPC and HPC, but about the spools, they have to know.
They have to know. Okay, they have to know. Okay. Fine. I just will grab you a small diagram. I think I don't have a spools diagram. Okay, I will mention you certain if I find it, Penny. Spools, right? There are high pressure compressor and low pressure compressor. let's assume there are two compressor stages. Okay, as if now we will go in deep later on. Two compressors, which is high pressure and low pressure. As the diagram says, as the name says, low compressor, for example, it will pressurize the air from let's say 0 to 5 bar. High spool continues from 5 to 10 bar. Okay, it will increase this pressure more. During the start of the engine, LPC low pressure compressor provides you the air for the conditioning, right? And a high pressure produces the later on, while after certain 30% of the ideal RPM is reached. Have anybody know about seasickness or altitude sickness? Anyone heard about it? Oh.
They heard about it, but not exactly. The terminology might be not aware for all the people.
Okay, so finally I see someone replying. Okay, so the thing is like altitude, our body is accustomed to certain pressures. Okay, what you say is like every air has pressure, right? Soumya, I think they have pressure, this atmospheric charts, right? Like
Yes,
pressure
that's
decreases from water, reaches a higher altitude. They know it, right?
Yes.
Yeah. Okay.
You're perfect with that knowledge.
Yeah, that's great. So nothing. So when you are on land, you are accustomed to certain pressure around your body. So even your heartbeat, the pump in the heartbeat at a certain pressure, right? Your blood. So those are matching with the surrounding, and that skin will be wrapping around it. So it will be meeting. But when you go to certain altitude, the pressure drops. What happens is your inside pressure is more than your outside, maintaining the skin thickness of your body. That's why you will be feeling certain dizziness, because the oxygen which has to be pumped to the brain will not reach it properly, because your heart is not pumping your blood properly. Because heart, lungs go in synchronous system. It's biology. No need to read about too much in it. So aircraft also works in the same principle. So there is a limitations like 6 bar, where the pressure inside the aircraft and outside atmosphere should match. Okay. So when the aircraft is flying for wide body, mainly wide body and a high end narrow bodies, there will be a air conditioning systems where it will be maintaining the pressure of outside inside pressure with respect to the outside pressure. Okay, those pressure maintaining as well as the temperature maintenance will come under air conditioning system, which will be controlled by the pilot. Pilot doesn't work on it. He just sets how much temperature or pressure. Pressure is automatically controlled, but he can also manually set it. Mostly it is automatically controlled. He will be setting the temperature, but manually most of the time, because depending on different region, he will be setting that comfort zone, right? 22 degrees, 21 degrees, 30 won't be there, 25 degrees, something like that. Okay. So that is all the air conditioning system. Autoflight, which is again avionics. I don't have much knowledge on it, but after the flight part is set, you can just set the controls and you can just let it autoflight go on during the flight part, unless until there is an external factor affecting the flight path. Okay, sometimes the other aircraft may change its course, or the attitude, or there is a thunder, storms, everything that affect the flight. Apart from that, autoflight can mostly manage the flight paths. Okay, and communication is nothing but the transaction between control towers and the pilot, where they will be guiding them if there are any uncertainties during his flight or during landing and takeoff, like clearancing of runway path and all those things will come under communication equipments. Electrical power, again, 22, 23, 24 is related to avionics part. Electric power is nothing but AC and DC, as you know, alternating current and direct current. As most of you guys are from aeronautical background, and I can assume that you guys don't have what is AC and DC, but if you want to come into manufacturing side, you guys definitely should know what are the effects and defects of both, and where it can be used and where it cannot be used. Just a small note: DC power can only be stored, AC power cannot be stored. Okay, just a thumb rule. And short Small aircrafts mainly work on DC. Large aircrafts have both AC and DC power supplies. Okay. 25 equipment and furnishing is not main topic, but it is a subtopic of all the aircrafts. Like if you want to repair a wire, a small wire, it is held by a rope. I mean, we will call it tie rope. So those all things will come under equipment furniture. If it is a fire protection system, how it is nut and bolt are holding. So it's a subtopic of all topics. Anything you have a subtopic doubt, you will be going to equipment and furnishing. Okay. Fire protection. If again, fire protection is a lengthy topic. Let's say there are three things that will be catching a fire, right? One is you need a fuel. Next is a oxygen. Other is a ignition. Okay, ignition, fuel, and oxygen are the three main requirements to catching a fire. Okay, so ignition can't be controlled because you can have a short circuit anywhere in the fuel tanks as well, because there are fuel quantities kept in the fuel tanks, right? So which is an electrical component, and even the when you are struck with the lightning or anything which passes to the little drips, there may be a static or dynamic current in the fuel tanks which might lead to spark. So you can't control the ignition, so excluding it. Other is fuel. So fuel tank is itself having a fuel, right? So you can't even remove the fuel from the fuel tank. So third part is oxygen. So if you remove one of the component from the other three components, you will be preventing it from catching a fire. So most of the parts will be completely pumping out the oxygen from the aircraft. Okay, that's why there are having air vents, dumping dumping walls and all those things, which will be making sure that oxygen is not staying in the fuel tanks and all those things. Okay. And fuel protection system is mainly classified like two types. Like one is a fuel probes and other is a fire probes, and other is a fire detection loops. Loops are nothing but a continuous detection of sensor, which will be depending on material, chromium, nickel, and inconel tubes. Those types, and generally fire sensors are like a fire loop, like a what you call I forgot fire loop. Okay, those are mainly described as a fire sensor, single point sensors and the fire loop. So depending on where you have to use them, it will be changing. So again, it's a big topic. Flight controls, again, it's an avionics part 27, which will be mostly controlling all your movable parts like rudder, flaps, ailerons. So it will be dealt with both avionics and mechanical part as well. For example, motors which are used to move the flaps are dealt with the electric avionics guys, whereas the controls, which how much it has to be moved, like hydraulic and all those things, will be dealt with the mechanical guys. Okay. Fuel, again, fuel is a big topic which I have a certain slides. If time permits, I will be discussing few of them with you. Hydraulic power, it's also, I think you guys have a brief knowledge of hydraulic, but it's one of the what you call very depth topics in the aviation industry. Okay, hydraulics and pneumatics, you know, a small amount of power change is required to operate a large amount of force. That's why we use a hydraulic power. Okay, next, ISN protection system. This sounds a little sketchy, but when you are what you are moving at a certain height, for example, if you are going on a bike without a helmet and running a very speed, sometimes you will find a moisture on your skin, or you will be getting a tears out of your eyes, right? It's mainly because you are hitting air at a certain speed. Okay, you are changing the density of a air speed with due to the impact. So assume this for an aircraft. You are hitting an aircraft with a high velocity of air which is stagnated at that point. So what happens is it will be converted. The air converts into liquid or solid form, ice, because the molecular structure changes of it depending. Okay. So, but you can't let ice form on the wings or shields, right? Ice shields are nothing but screens of the aircraft, like mirrors of the where pilot sits. Okay, you can't let them get ice and get blurry that pilot can't see outside what is happening, right? So those oil and air protection have like there are systems to that ice using some rain protection repellents, and there are some sensors which record how much ice is forming and how much it should be liquid should be spilled on it. Okay, those are coming under ice and protection. And 31 again indicating and recording 31 chapter, which is like your black box. We discussed, right? Recording, it comes under that. Landing gear, again a big topic. Each and landing gear has a operated controlled by electrically controlled and hydraulically operated. Okay. Recent all aircraft we call that fly by wire. What it means, like you don't need to open the door mechanically. You just have to switch the button and door opens, right? So that means you are giving an electrical input, but when you are opening a door, electricity can't open it. So what happens is like hydraulically the doors are opened using an actuator. So that's why we call these systems as electrically controlled and hydraulically operated. Okay. And lights, again, there are different types of lights. Even on the wing, there are red light and green light. Right side is green light, and left side is red light. Because see, when you are seeing the aircraft from the far, seeing the lights red and green, you can say which direction the aircraft is flying. So that's why they are kept at different types of lights on the aircraft. And not only that, there are different lights on the bottom side of the aircraft as well. When you are even for next time climbing the boarding the aircraft, just check the bottom part. There are like 3 types, and 2 on the one on rudder and 2 on wings, and clearance lights while working for maintenance, emergency lights. There are very different types of lights. Okay, so there it's not that much depth, but it covers a huge area. And every light has its own intensity, frequency, and flickering effect. How much it should flicker is also depends on the type of light. Next is the navigation. Navigation is also like you can see a communication, right? But communications are systems like electronic devices. But these navigations are mainly these control towers. If you see an aircraft, at the bottom belly, there are something like a fins, like a fish fins. It will come out small fins bottom at the aircraft. Okay, if I can show you something. There are small fins at the bottom of the I'm not finding it. If you can see here on my screen, you can see this white color, right? My mouse, you can see my mouse, right? Circling. There is a small fin-like structure. Not only here, at different part of the fuselage, there will be a fins, which are towers, signaling towers. They will receive and send information. Those are those for, and some of them are even in the rudder. Okay. Rudder is not clear. Okay, so if you can find while boarding the aircraft next time, just check it. You will be finding different signals. The larger the antenna, the smaller the frequency it sends. Okay, length and frequency are inversely proportional. So those again comes under completely avionics component. They will be taking care of it. And oxygen, as you know, you need oxygen in the aircraft, right? There is a certain system which pumps the oxygen to entire aircraft. During emergency, this is mainly the air intake from the engines is sufficient, but during emergency and certain weather conditions, this oxygen cylinders, huge cylinders are kept during the at the forward bay of the aircraft. I mean, forward fuselage compartment bottom. If you are boarding the aircraft, mostly you will board from the left side. When you are boarding, just check a small part will be there. Let me find if I can. These are also like it's taking time. This is so yeah, clearly it is here, the navigation one which we were discussing before. Okay, and okay. Okay. Exactly here, if you see my mouse here, there will be a small door here, which the oxygen cylinders are kept. I can't think to zoom the aircraft pretty well here, but if I find anything, I will. Okay, if you see my screen, here is the door generally which you guys will enter. Here bottom there will be a small door, okay, which is known as the oxygen compartment bay, where the oxygen cylinders and related equipments are kept. So there you will be finding the oxygen one. Okay. And pneumatic is similar to hydraulic. Pneumatic we hardly use in the aircraft, but landing gear, which is mostly the pneumatic version. I mean, only in landing gear we will use the major component of pneumatic. Landing gears are operated oleo-pneumatic, means it is comprised with both oil and pneumatic system. It functions on. Okay. Vacuum is not much of the topic. Water and waste, like lavatory and everything, water used water, input and output of the aircraft should be used, right? From left side, mostly we will be taking the fresh water system, and from the right side, we will be dumping the wastewater system. And how to connect all those things are in that. Okay, and rest of them is not of much importance. Okay. Any questions from this topic? These are the system, because these are the main way. In whichever industry you go, you will be selecting one of these things and the next slide. So you have any questions on these topics? Soumya, shall I continue?
Yes, you can continue.
Okay, I will just fast forward a few, because I think it is almost 4, getting 4. Okay. Structures is nothing, you know, right? Like stringers, web. I think Soumya, these guys know about like stringers, what are ribs, what are difference between longerons.
Yes.
Yeah. So okay. So even though the component in the fuselage and wings have the same purpose, like taking the lateral and rod or twist loads, due to this location, then every structural component is named differently for the convenience of replacing or repairing it. Okay, so that's why you have a different names. You may think while reading why these have a different names. Mainly during that purpose, during repair, it will be easily accessible. Okay. So depending on like different areas, you will be calling as different names. Okay. Doors, like doors which will hold the air pressure in and out, cargo doors and normal passenger doors. maintenance doors, everything comes under door structures. Okay, fuselage is nothing but from what you call bulkhead 0 to bulkhead 67, I think 74, depending on the aircraft. You will have the bulkhead. So that nacelle and pylons are nothing but the component which hold the engines, right? From the wing between engine, there is a structural component which is very delicate and highly means engine is one of the heaviest component in the aircraft, but it is held by a small structure similar to the aircraft, which is a big body held by a small landing gears, right? Similar to that, these nacelle and pylon are also very important topic structure. So it is even though it is just between fuselage and engine, sorry, the wing and engine, it is regarded as separate topic. Okay, stabilizers, stabilizers, vertical stabilizer and horizontal stabilizer, the entire like after the wing part, elevator, rudder, ailerons, everything comes under stabilizers. Windows are also very important because a small scratch in a window can make an aircraft crash. I think even this is a very interesting video in YouTube where there was a small bolt loose from the aircraft fallen out of the aircraft and where the aircraft has crashed because of that. I will share this video also, YouTube link also with Soumya. You can guys just get from her. And next is the wing. As you know, one of the main cantilever beam, the best example of the cantilever beam is a wing, which you guys will be studying more. But wing is very much topic with the ribs and all those. Even it contains the fuels, right? Depending on the how much fuel it has, it will the load of the wing changes and lateral stability also changes. Okay, we will be discussing it. And next is the propeller. Again, it's a brief topic, propeller engine regarding its chapter 60, and the turbojet engine or power plant mainly engine main core part will covered by the ATA chapter 72. So 60 and 72 are engines, and every topic related to engine oils or engine fuels, everything will come from 70 to 80. It covers the power plant, means entire engine structure from the left side. And 85 to 100 are not much of the system. It's too deep. If you want to go into the system too deep, these are miscellaneous and you can read it through time, but most of the time we never read them. We mostly go from 20 chapter to 80 chapter, and which is the highlighted one, only those are we will be considering more. Okay, that's it guys for maintenance thing. And if time persists, I also have a topic on fuel. We can cover it depending on your coordinator, Soumya. Okay, any questions from you guys? Soumya, any questions?
I think so. It would be better if we go into the next topic.
Shall I go it? Okay, fine.
Yes. Anyways, we are having half an hour time.
Okay, fine. Fuel, right? As I said, there are many ADA chapters, right? You can. I asked your coordinator, but she said we can go with the fuel because you guys may have a brief idea, and I heard like you've gone through some types of fuel sessions as well in the past. Okay, so fuel tank. Anyone know where the fuel is stored in the aircraft? Soumya, they are still online, right?
Yes.
Yes, wings. Yeah, good. Someone answered me. Serboom. Sorry if I spelled it wrong. Serboom, I guess. Okay, wings. Fuel is stored in two places, wings as well as in fuselage. Okay. Depending on the type of aircraft, so some of them don't have in fuselage, but all of them will be stored in wings. Okay. So, for example, if we take a Airbus aircraft, let me Okay, let's assume this aircraft. Okay, I'm making it. Okay. Okay, I'm making it big. So let's say this aircraft. Okay, this is this is a narrow body, not a wide body. Okay, because it has only 32 length and 4 rows. Okay, 32 columns and 4 rows. So it's a narrow body aircraft. So a high end version of the narrow body and a wide body has a 3 tank system or 5 tank system. But mainly 3 tank system is nothing but wing, 2 wings, wing left, LH wing, RH wing, 1 and 2 wing, tanks and center tank. Okay. And for small aircraft like this ATR-1, we have only engines in what you call wings or itself. Okay, so mostly the fuel is stored in wings and fuselage. Okay. Okay, so fuel system mainly consists of these what you call these subtopics. Mainly, I will be discussing about the fuel storage as of now, but these are, it's also, as I said, every system has its own depth and it cannot be covered in like 20-30 minutes. So I will be going a little fast from now on. And this is our, okay. For example, fuel system consists of fuel, definitely storage. Storage is nothing but the areas with it stored. Tank is the enclosed areas. Okay. That's a between with the storage and area. Storage is like how you will be inserting and those things. Limitations, how much pressure it can, those all things will become tanks dimensions. That's all the tanks covers. Okay, tank vent system, venting. Anyone have you ever filled air in this bicycle? Not the pump type, the old version one where you will be pumping it. Anyone tried it? Yeah, guys, it's a simple question. Come on. You can raise your voice. Have you ever tried the pumping of air? Okay, that's too silent. Soumya, we are still connected, right?
Yeah, they are connecting in the chat box.
Oh, okay.
Everybody is watching live.
Okay. Yeah, sorry. I just forgot to scroll down. Okay, fine. So this what you call watch this video. Okay. The air, the blue one is the air which comes from the outside. Then it's fill this pressure part. After it's getting closed, the air is pumped out. Okay. The bottom part no need to be liquid, always be the air. Okay, it can also be fuel. Okay, but the fuel to be pumped out, it should have a certain pressure inside it to be developed so that it can be pumped out of the system. So you need an intake. Okay, so that's what tank venting system is like. If you keep on pushing the air fuel outside, there will be a vacuum created at a certain point so that you can't pump the fuel anymore. So the empty space created by the fuel which has been pumped out or engines used should be occupied by a different matter so that the ecosystem should be maintained inside the wing, right? So this ecosystem to maintain or the sorry, or the air to take inside the fuel, I mean air to occupy that vacant space that fuel has created, you need a certain system. That's what we call it as tank vent system. Okay. And tank fire prevention, we have already discussed about it. As we can't exclude the ignition and the fuel, we have to exclude the oxygen, which will be, it's a deep topic we will be discussing later. Quantity, there are different type of quantity sensors. Have you heard the term capacitor anytime? Anyone, you guys know what is capacitor? Capacitance, capacitor, resistor. Soumya, are they knowledgeable in electrical basics or?
Yes, they are knowledgeable in the electricals.
Okay, fine. Okay, I don't know.
They are
I
giving
can't.
the text in the chat.
Sorry?
They are texting in the chat box.
Okay, yes. I think I have to scroll this down every time. Okay. Fine. So you guys know capacitor because it's explaining is gonna take time. So the oil quantity is depending on the capacitor, means definition of the capacitor, the capacitance, the oil quantity is measured. So these we call it some in non-technical terms we call it as floaters or capacitance quantity devices. Okay, so quantity is measured using that. Tank level sensors also quantity level sensors, but these also give the indication how much each rib is having a fuel quantity. Okay, how much height it is maintained, or it should be flowed down, or it should be pumped up to the ribs, kind of stuff. Okay, magnetic indicators are nothing but also fuel sensors as well as chip detector sensors. I should have a diagram of it, I guess. Yeah, this is the fuel level indicator, that capacitor type 1. Even magnetor type 1 is also like this itself. So it will be like this. Okay. Next, tanks, as you know, storage tanks. In tanks, you will be mainly having like intercellular transfer. What is that? We will be discussing distribution, fuel recirculation, fuel pump, cross feeding system, refueling, defueling. What are those? We will be discussing in few minutes. Guys, just a question. For example, I have a more fuel inside the left wing, and okay, let's talk about storage. Then I will be having a question. This one, okay? Fuel storage. I took a like a normal version where fuel tanks are stored, like basic version. So in this basic version, you will be having a three tanks. One is a center tank which is inside the fuselage, and two tanks, LH and RH tanks. Okay, and this is for mainly A320 aircraft. So I just mentioned the amount of fuel it can contain. This is the maximum amount of fuel it can contain. Doesn't mean it will all contain this maximum. Okay, this is manufacturing limitations. But considering the factor of safety, as 82,000 liters can be kept in the center fuel tank, assuming the factor of safety, only 7.5 tons, means 7,500 liters are only kept in the center tank, and only 6,000 liters are kept in each tank for safety precautional purpose. Okay. And from RIP 1 to RIP 22, it is spread across the whole fuel. Okay. And few of the wings are also subdivided. Like, as I said, some of them have 5 tanks, right? 5 tanks are nothing but a wing tank is divided into 2 tanks. Left, like 3 and 4, you will just give the numbering, or inboard or outboard, inner or outer cell, depending on the type of aircraft, because each and every manufacturer uses its own terminology to define those tanks. Okay. Fine. So this is like let me. This is a what you call a schematic diagram of the tank, how it will be defined. Okay. Water involved. Okay. Fine. LH and RH vent tanks. Here is the center part is the center. You just follow my mouse for a few minutes. This is the center tank. This is LH inner tank, and this is outer tank, and this is the vent surge. Means if any fuel while filling it comes across this, it will overflow into this and get dumped outside. Okay. There will be a 2 valve. This is what you call a pressurized open valve, where what happens is like a seal. It is like a seal. If certain amount of pressure is applied, the seal gets automatically broken and the fuel gets dumped out. And this amount of pressure is dependent on the amount of fuel it is getting stored inside the tank. So pressure is nothing but other form of weight, right? Pressure is force per unit area, right? So in a certain amount of area, if you are dumping more fuel, the seal gets break and fuel gets dumped. Okay. It won't break otherwise. And okay, now my question is, for example, I have pumped more, I have fueled more fuel into the refueled more fuel into the left RH wings. Per se, RH wing has like 6,000 liters and LH wing has only 1,000 liters. What will happen? Guys, you understand question? It's a basic question. If RH is given more fuel like 1,000 and this 1,000, if there are like 200 300 liters, it's not a big problem. But if when you have a difference in 1,000, it's a problem. So what kind of problems does aircraft faces? No answers. Does anyone know what happens when one side of the fuel is more than the other side?
Check chat box.
Chat box, huh? Okay, weight imbalance. Okay. So what happens when weight imbalance happens? Yash, if you can speak, or just you can type it. What happens during weight imbalance? Guys, it's one of the basic topics you will study in flight stability. Okay.
Someone texted in the text like it leads
Weight
to
imbalance.
crash.
Okay, fine. I haven't got it. Okay, it's lead to what? Crash. Okay, yeah, crash will happen. Just, but before that, what exactly happened? Crash is nothing but a failure of aircraft systems, right? But you, as an engineer, see, outside people can tell it will crash, but you can't say it. You guys should be defining a problem. What exactly happens? When you can only define the problem, then only you can get the solution. Weight imbalance, roll moment. Yeah, that is better answer. In other terms, I can say same what the Yash has texted in the group chat. What happens is CG shifts. Okay, the CG shifts from one point to other part, which causes, as the Yash said, the roll movement. I think you guys should. I'm just opening an image. Imbalances like instability. I think if fourth years, I think it will come in. I don't know which year you guys cover aircraft stability, but this is the one of the basic topics you study during stabilities. Okay, and this is the diagram. When you have a fuel thing, you will be having lateral instability. Okay, longitudinal instability along the lateral axis. Okay. So what it causes is aircraft to roll, and which, yes, in turn may lead to crash. Okay, for example, the already aircraft is in air. What can you do to rectify this problem? Anyone? Guys? What can you do to rectify its problem during ground and during air? Anything you can answer. Okay, Soumya, still anyone is texting, or shall I continue?
You can continue.
Okay, yeah, I got it. On air, we can increase fuel flow rate from wing which has more fuel. Okay, okay, but it's technically okay. I can agree with you, but practically no. As I said, if you have a few liters difference, what you said might have worked, because both engines can take. There is no rule saying that engines can take left engine can take only fuel from left engine and right engine can take only from right wing. You can pump both fuels. Right wing can left and right engine both can take from right tank. Okay, but this can only happen when the difference between the fuel tanks is only a few liters, like few hundred, mostly at max 1,000 liters. Okay, if there is any much more difference, like higher version, you have to dump the fuel in air. I think you guys heard of fuel dumping, right? They just open the wall of the fuel and the fuel gets falling down like a water on the air. It doesn't fall down on the ground because fuel is very volatile and it will get evaporated before it touches the ground. Okay? Is it clear? Soumya, any questions regarding it?
No, they are having idea regarding fuel dumping.
Okay, that's good then. If you are having, so they just open the left tank, right tank. As we are discussing, it has more. They will dump it. But as you shared, if you have a very few liters difference in hundreds or mere thousands, then yes, you can. No need to consume more. But what you do is like you will pump both the engines from the single tank itself. Single tank itself instead of using the both tanks. Okay. How you will do that, I will be discussing later on slides. And when you are on ground, no need to dump it. There is a ground mechanism with a transfer of fuels. Even I will be inter-cell transfer or distribution, right? Or fuel recirculation, cross-feed system. These 4 topics, 1, 2, 3, 4, and 6 points will be related to that. How the wing from one wing to you can go to the other wing. You can use those systems during only on ground, not on air, because it has many defects while it's running. So it is not used during the air. Only on ground you can make the fuel transfers from left to right or right to left or center to right. Okay, how it is done, I will show you. Before going depth in the fuel systems, distribution systems, do you guys know what are valves? VALVs. Anyone? I'm waiting for your replies. Yes or no? Anything is fine. You can even type no need to
yes.
wait. They know valves.
Yes.
Okay. Yes. Okay. Valves. Valves are, you guys may know, it's nothing but a door. It's a small version of door where you are letting the fluid or hydraulic fluids, mainly air or liquid, pass through it. And there are different types of valves, but and different types of classifications as well. But I took one of the classifications depending on its movement. Okay. One kind of valve is like pressurized valve, where we have discussed before here, where this drain valve. Water drain valve. That is different valve. Okay. Fuel drain valve, fuel dump over pressurized valve will be there. Where what happens is, if after certain pressure, the door will be moving in one direction and the fuel flows till the pressure is opposing the spring friction. Okay, assume a spring. Let me see if I can. Yeah, this is the better diagram, I think. Okay. If you can see, for example, flow is flowing from the bottom. Okay. What happens is it pushes the door up. Okay. Here it's doing something else, but if it pushes the door up, it can go through the spring, like left side. Okay. Door is up. If it doesn't have a certain pressure, the spring will close the door and it will be sealed here. Air will be stagnated here. Okay. Only once the fluid overcomes this spring force pressure, it will go from here. Okay. So pressure and force go hand in hand always, because pressure is nothing but force per unit area. Okay. And there are types of doors which are controlled electrically, like with motors. I just, for example, you have a what you call anywhere. How can I say it? Okay, in a car you will have this automatic doors, right? Closing of window. When you do the switch up and down, it will window will close, right? With the electrical system similar to that kind. The electrical impulse is servo motor. Servo motor is specifically for this kind of valve, which the amount of electricity is converted into number of rotation. The door should be rotated. Angle should be using that. The valve is operated. Okay. Electrically controlled hydraulic operator means you can do with both. Sometimes you can electrically control, or otherwise you can do with the hydraulic push. Okay. There are different types of valve. It's again a huge topic, and I will just let me share you this link in the session again later. So this is a newly video I've just while Google I found it, a Tesla valve. It's very interesting. You can voice watch this thing. Okay. Okay, let's enter our main topic. Fuel system. Okay, Soumya, it's 4:20. Shall I continue or?
Yeah, you can take 5 more minutes. After that, we will wind up the class.
Okay, fine. Guys, I will just speed up this session. Sorry, it took a lot of time briefly in intro. This you see like two pipelines, right? The black and white, right? The white pipeline, this bottom one, is nothing but the fuel tank system pipeline, where from here the fuel is fueled into the aircraft and stored into the wing. Okay, but you have to, from here to go to here, the black line, you need a booster. Like you have a fuel inside the tank, but you have to give a certain pressure to the aircraft engines, right? So to that, there is a booster pump 1 and 2. Each tank has its own 2 booster pumps, because if one fails, other will take into section. In aircraft, every system is doublet, means if one fails, doublet or triplet. If one fails, other has to take care of the failure one. Okay, hydraulic system is a triplet, blue, green, yellow. If one fails, other will take care depending on the type of system. Okay. Now 1 and 2. So the fuel is first, just follow my mouse, fueled into this, and if this valve, refuel valve, is open, it will go into the what you call fuel tank system, and this will be always closed unless it is pressurized. It's not much of the use. Even it's open, if you don't have pressure, it's not much of the use. And it's go to the right wing, and it will go here. Okay. If you close this valve, the fuel will only be getting fueled into the left wing. Okay. Now, after you fuel this line, if you want to pump into engine 1 or 2, means you have to use this wing, left wing. You can on 1 or 2 pumps. Okay. For example, I am owning pump number 1 or 2. Nothing will happen. From here, follow my mouse. The fuel flows from here to here and here. Okay. It will go in 2 directions because it has 2 directions. Okay. It will spread till here and spread till here. Okay. If you close this valve, the fuel will not go into the tank, engine, and here it will get stuck. Everywhere it will get stuck. Okay. Then you have to open this LP valve so that it can go into the engine number 2. Okay. After getting into the engine number 2, there is a certain, again, a brief thing, but the fuel gets engine gets started. Okay. Let's go to the left side now. Like this it goes, and this fuel will be off unless you are defueling or refueling it. And this is booster pump, so it's a dead end. Okay. So it will be going here. Okay. Cross bleed valve is nothing but a bleed valve between both the engines. Okay. If you open it, it will go like this and go into the like this and go into like this APU. Okay. If you close this APU wall, it will go into the APU. If you don't close this wall, it will be open this wall, it will go into the APU. But again, from here to here, it is taking a lot of travel, so pressure drop will decrease. So you need a APU pump to start the APU engine. So because fuel should be injected with a certain pressure, fuel nozzles, unless until you will have a certain pressure, it won't get a distributed what you call a distributed propulsion system. So even here you get fuel without owning the APU pump, you will get much problem. Okay, so valve should be open, APU pump should be on to get into the APU. Okay, I close this valve as well. Then it will go, booster pump is a dead end. Again, it will go to this booster pumps is a dead end, because booster pumps means it takes the fuel and pumps inside it. It can't allow the other way. Okay, it's only one way. So it's a dead end. It will go to here. Again, if you open the LP valve of first number one engine, it goes to the number one engine and number engine just starts. Okay, from this, you can use, as I said, you can use the left wing or right wing. Similar to right wing, you can use any of the booster pumps to propel the engines. Okay. Again, the fuel pump is inside the aircrafts as well, which they pump aircraft here, increase the pressure. And if I'm missing anything else, above and bottom dotted lines are representing the pipelines of above and bottom lines. This white pipeline represents by this dotted lines, and black line is represented by this dotted lines. So anyone have any questions regarding this? Soumya, any questions?
Nothing much. You can carry forward.
Okay. This can be discussed in yeah, that's what I'm wrapping up. This is like a very much depth topic. I just want to give you a briefing, like one of the engines, so that you can understand what are the characteristics we defined in our previous slides. I mean, first PPT. And this is air vent system. NACA air vent, we call it because it's shaped in the NACA series, like NACA 4 series, 5 series, you guys should know, right? So the, that NACA series, it's shaped in that, so that's why it's called NACA. And this is what the air intake from the fuel is goes into the tanks. What happens is amount of fuel used, the volume should be what your equal amount of air should be filled into the tank, so that it will have a continuous flow. Otherwise, bubbles will be formed, and thus leads to the fire at certain point. So that's what air intake is, vent. These are in depth of the fuel systems, strainer, fuel pumps, because even you have a fuel pump, there are release valves. Many things come into picture. We can discuss this later, or if we have any other sessions. Just even there, till now we have only discussed the mechanical part. Every system has its electrical and mechanical versions, right? So this is the electrical version of it. Let's check first the bottom part. Engine fuel control and distribution is done what we have read. Even distribution system from left to right tank. Okay, this is between engine and tank. This is internal tank. Both are with the storage system and controlled by this system. This is all the CPUs, means chips. Okay, this chip controls this and this, and also gives the indicating how much this distribution is going on, or how much fuel is dumped, or how much fuel is late. Quantity, distribution, everything. Okay, you need electrical power to operate this, right? So this is the battery power, and this goes to warning. So these are all done internally, like motherboard. This is a motherboard, and this black box which I highlighted is like a screen, display screen. Okay, if you have a over fuel or less fuel, it will be sending to this warning system, which will be cautioning us with red or amber color light, depending on the severity of the issue. Okay, ECAM is nothing but the display systems. These are two both computer systems which will be showing the readings. Okay, that's it. Fuel level indicator, which I just finished. This topic, let's exclude. We don't have time. I will discuss this later. Yeah, thank you. That's it. So, do you have guys any questions regarding this topic?
Actually, Sai, there is a lot of questions that I have received to the chat box. So
Okay.
I'll be forwarding the questions to you. You can answer me. I'll forward to the same students to the later.
Okay, fine.
But now we have run out of the time.
Yeah, I run up of the time. Yeah. Okay. I should have planned only one PPT, I guess. Two PPTs are more for 2 hours. Okay. So anything else, Soumya?
You know, thank you at last.
Yeah, sure.
I'm expressing my vote of thanks to Mr.
Yeah.
Sai. Sir has spared his precious time and shared knowledge, experience with us. I'm thankful to Parul University for organizing such informative webinar session. In future, I hope we will again connect to knowledge sharing. Thank you once again. Thank you all.
Okay, thank you guys for the patience. Okay, bye.
Bye.